Okay, good afternoon or good morning, good evening to everyone. Today we're going to be looking at the lab 2462, 426. We're going to be looking at lab 426, working with text file in the CLI. The Linux environment is majorly a command line based environment. So what are some of the objectives that we want to look at in this lab? Graphical text editors, command line text editors, and working with configuration file. What we need in this resource is about our CyberOps Workstation virtual machine. So I will just go ahead and activate that. I open up the virtual machine. So what's the instructions like? Before you can work with text files in Linux, you must be familiar with text editors. So there are several text editors. So text editors are one of the oldest categories of application for computers. Linux, like many other operating systems, have different text editors, right? So some text editors focus on the programmer and including which include features such as syntax highlighting, bracket matching, find and replace, multi-line reject support, that is a regex support, spell check. So regex are kind of a text that with respect to how would I put it now? You have your characters that are not your normal text-based characters, like your comma, full stop, colon, semicolon, all of that, especially when you're trying to do some kind of formatting. So it could support all of that. Spell check and programming focused features. So there are several text editors that can do that. So to save space and keep the virtual machine clean, the CISCO CyberOps Workstation only include SCITE, which is a graphical text editor. It then means that it will look something like a WYSIWYG. WYSIWYG is what you see is what you get, right? So just like your Microsoft Word, there you could bold, italics, underline, and the rest. While some text editors don't have those features. So I open my Oracle VirtualBox, get to my workstation, and I start it. I mentioned earlier on in previous lab that it's good to increase your base memory so that you can be as your machine and whatever you're doing is going to be as fast as possible. So that is loading up. So the choice of text editor is a personal one. There's no such thing as best text editor. That's normal, just like browsers. You have Chrome, Firefox, Opera, Safari, and whatever. There's nothing like best. It's just a matter of choice. Step one, open SCIT from the GUI, right? So I will wait for my machine to start up. So let's just go through the entire lab and see what we are up to. I'll log on to the CyberOps VM. You log on through this default username and password. Navigate to applications, this, launch it. Once you launch it, understand that it's a simple but includes important features. You could have tabs that say you could have multiple tabs, just the same way I have this program, I can open multiple tabs, just like your browser. And the space is big, really big. Okay, you're asked to type this item here. We'll copy this item and paste it into the text editor. Spend a few minutes with SCIT in the main work area, type or copy and paste this item. So I will copy it and put it in my clipboard. I think it includes this also. So I copy this, wait for this guy to launch. It's not yet up. Now you are told to save the file. Notice that SCTI attempts to save the file to the current user home directory, which is analyzed by default. Let the name of the file be space.txt and save, right? You could close the editor using the cancel button. Then you reopen this. You click on file, open, and see if you can search for this particular item. The question here is, could you immediately find space.txt? The answer is no. So we're going to know why that happened. Here we're trying to understand the Linux environment for this particular CyberOps machine. Okay, good enough. It's up and running. So the password is CyberOps. I'm in. We'll cancel this guy. Cancel this guy. I'll wait for that to load up, my desktop to load up. So I'm going to run through all of these steps now. That is step 1A to GH, right? I'm going to run through that now. So let me just wait for some seconds for my machine to load. Even still on 6 gig is kind of slow. If you have up to 16 gig or 32, you could give it more RAM so that the machine can be a little bit fast. Okay, good. The machine is about 3 gig size, a little bit more heavier than the Windows system. Kind of. The Windows system is a little bit, I think about 2 point something gig or so. So application, I'm told to go to CyberOps, Scit, that's the text editor. I've copied the guy. I'm told to paste it. Paste. Okay. Let me copy again. Space is very big, really big. Copy. Paste. I should have paste here. Okay, it should be in edit. Paste. It's not pasting. I think it's not. Let me go to device. Rather input keyboard. Keyboard settings. Host.delete. Let me go pick this again and see. Let me come and paste. Still didn't paste. Input. Okay, let me just type. Normally it has to do with my input device. You could select which of the hosts you want to use. Let me see. Okay, let me just type something close. So anything close. Okay, space is big. Space is big, really big. You just won't believe how vastly, hugely, blah, 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 hello world, just something, right? Douglas. Adams, right? Just anything, right? That told to save it. You see, just like you are told. I'll expand this. I'll also expand this, my environment, so that everything is big, I can see. So save file as. So it's trying to save in the home analyst directory, just like we saw in the lab. So you are told to go to applications, CyberOps, Scit, the text editor, type something there, click on file and save. Notice that this is trying to save the file in the current user's home directory, which is analyst by default. And that's what's happening here. It's trying to save here. Of course, I could go back and want to save in the desktop, but by default, it's trying to save here. So name the file space.txt. Click on save. So name of the file space.txt, right? I save. So this is the file. I go back to the instructions, close the Scit by clicking the X icon on the upper right side of the Windows and reopen it. So next thing I will do, I'll close it. Then I'll go and reopen it. So I think I'm now told to click on File, Open, and try to search for this file, if I can see it. File, Open. You see, it's not listed here. That's the import of the lab. It's not listed here, right? I can't see it. Even though it's indicated all sources, but still I cannot see it. So the question is, could you immediately find the space.txt that you just saved? The answer is no. Now, the next one is, even though Scit is looking at the current directory, this is not displayed. This is because Scit is looking for known extensions, and the txt is not one of them. To display all files, click the drop-down menu at the bottom of the open file windows and select all files. Drop-down menu, let's look for it. Here, you see all files, hidden files. So the point there is, all sources are sources that it can identify, but all files, hidden files. So let me just say all files. So of course, that's when we should be able to now I'm tapping on S, sorry. I'm tapping on S, you see the space.txt, I cannot see it, right? I cannot click on open. Of course, I'm going to see whatever I've typed. So understand that there are some files that can be hidden. There are some files that you might need to use the all files or use the asterisk to be able to view those files. Okay, same thing applies to Windows also. For your Windows machine, if you're looking for a file, if something is hidden, you might need to tap on .txt, rather, sorry, but I need to type .star, right? You're able to see all of the files, right? Assuming this folder was not showing up everything, right? Okay, so there's another one here. Step 2, alternatively, you can also open Scit from the command line. Click on the terminal icon located at the dock at the top of the desktop. So we go again. So I'm going to close this. Let me just close this. How do you access terminal? This is it. Come to the applications and click on the terminal. So the terminal is synonymous to the Windows CMD, right? So we are saying that another way you could open the file is to get to the terminal, which is step A. Type ls to see the contents of the current directory. I've done that before. So you say ls, right? So you see it? See the space.txt, because this is the analyst folder. If I do dir, I can still see the same thing. ls lists the files, directories, show me the directories, very similar commands. The next thing you could do is that you have this file, right? Now, if you want to read a file, you have to indicate the program, then indicate the file that you want to open with it. And the name of the file is Scite, then you say space.txt. Of course, it's going to open it up, right? So here you are saying, I want to open this file using this, right? Okay, so I could enter, I could cd into exit. Clear. CLS. Okay, I think I'll have to get out of this environment. So I use Control Z and I got out of this environment. So I'm back to this particular folder. So I could cd into this lab.support files, cd into lab.support.files, ls. Let me see if I can see another txt file. So I'm seeing a txt file here. So I still use scite space confidential.txt. It's still going to open the confidential file. So this is a very simple way to use that particular program to open text files, right? Okay. So this is what I just did. I did scite. I did space.txt and it was able to open the file. Notice that while this is open on the foreground, the terminal windows used to launch it is still open in the background. In addition, notice that the terminal windows used to launch this no longer displays the prompt. Why is the prompt not shown in the terminal? Because the terminal is running this and therefore unable to receive commands. So you see, once this is open, just a moment. Femi, I see you raise up your hand. You see, while the space stuff, while this guy was up and running, just a moment. While this guy was open, the space txt file was open. You see that I couldn't do anything here, right? Because it's assumed this file is still open, right? So until I did a Control Z before I could go out of this environment to be able to do anything. Okay, you're raising up your hand. You can unmute yourself and speak up.
Yes, sir. My question is it that there are a list of command keys? I'm not talking about the function keys or Control Z short keys. I'm talking about, are there a list of command keys like, take for example, you made use of the dir just now, and you made use of the scit now. Do we have a list of command keys that, okay, if you want to carry out this function, you must make use of this command key, just like the way you use the dir now and scit now?
Okay, fine. Yes, you have quite a lot of them. I will see. I don't know. Did you attend the program before this particular program? The module before this particular program?
No, this is my first attendance. This is the very first course I'm attending.
Okay, this is your very first course. So there was a list of Linux program. There was a list of Linux commands. I was here to forward it in the group for you. So you want to, or maybe I will drop it in the mentorship group. You want to know at least 10, 20, 30, 40, 50 Linux commands. Some of these commands apply to Windows. For instance, if I do ls is you, get me or dir, right? Get me a list of items within this particular folder, right? So there are lots of commands. You can also check up Google and say top 100 Linux commands. I will drop a link for you in the mentorship so that you can follow up and test some of these commands so that you can be able to move around. So cd is change directory. So when you say change directory, you are trying to move into another directory. Change directory downloads. So when you do that, right, you have moved into this particular folder. Then you can also say dir or ls is now going to list the items inside this particular folder. So you need to you can also type let me Control Z a moment. You can also type help, for instance, and you're going to see a list of several commands, right? And how to use them as some of the examples, right? If you type help on your command line interface, you're going to see quite some commands: bg, alias, bulletin, break, color, command, cd, right? And how to use some of these commands. But I'll drop a guide for you so that you can now start familiarizing yourself with the Linux commands. Would that be fine?
Thank you.
Okay, so I will get back to the labs. So, okay, I think there's something here about sudo. Close the instance of by clicking clicking the X icon, or by switching the focus. Okay, sudo, it's for, there are some things you might not be able to do with a particular program. So if you use sudo that particular item, it will help you to be able to, maybe to, for instance, edit the content or perform some functions that normally a regular user won't be able to do. That's why you use the sudo command. Okay, the part 2 of the lab is why graphical text editors are convenient and easy to use. Command line based text editors are very important in Linux computers. For instance, if I'm on the Kali Linux machine, I'll prefer to use Nano, right? It makes it more flexible, and you can edit right within your CLI, and you can also save. Using SSH, the user starts remote shell to the aforementioned computer. Under the text-based remote shell, the graphical interface may not be available, which makes it impossible to rely on graphical text editors. So you don't just want to learn how to work within the text environment, GUI environment. You also want to learn how to work within a text editor. Okay, so let's get to this place. In the terminal windows, type nano space text. So you want to use another program called Nano to edit this same document. So we will go to, and Nano is one of the inbuilt editors in Linux. So we say Nano space.txt. So are you seeing? So you see, if you watch very well, you can see that my environment is all within the CLI. It did not open a new tab. Space, look at it, GNU Nano 4.92. Space is big, really big. You just won't believe how vastly, hugely. Hello world, right? Douglas Adams. So I could use my mouse, my keyboard, and move and say, hello, we are just editing this document in our CLI, right? See the commands. Control X, you could exit, read file out, write out, where is, cut, justify, spell, paste, go to line. I think there is Control X. Control S is going to save, yes. So it has told us wrote 8 lines, right? 1, 2, 3, 4, 5, 6, 7, 8. Those are the 8 lines, right? You have one line empty here, 2 lines empty here, 1 line empty here. So 1 plus 1, 2, 3, 4, 5, 6, 7, 8, 8 lines. If I type and say, yes, we are learning basic Linux environment, right? So if I Control S, it's going to save, right? 10 lines. So 8, 9, 10. I could exit by saying Control X, right? I've exited that particular environment. If I go back and use SCITXT, am I correct? Okay, SCITE, I could use it and read this same file, right? It is going to open and show us those additions that we have made. So this is just you using 2 types of editors within the Linux environment to read those files. So if I want to edit here, I could say, yes, truly, we just used the SCITE as software or app to read the file, right? I could Control S, save, right? I could come back and say nano space.txt. You see the additions I just made here. So I'm using 2 types of application to read same file. Okay, so what else? In the terminal, type this. Okay, we've done that. Nano will launch and automatically load the text file. So anything here that makes sense? Anything I need to add? Control X, yes. Control X will exit Nano just like I did. You could use escape, you could use alternate, just like all of those commands you have here. to get help, to write out where is. I think you could use control, that is W, right? You could search for something, right? If I search for used, if I hit, see it as highlighted. I can use control W, which is where is, and look for file. You see it as highlighted. Because several times I've worked in a Linux environment. If you want to open up a file, edit it within your environment, still save, you must be able to know how to move around this environment, right? That's just that. So you have the command here. You can also check out, there's a help here, right? You could go online and read the documentation. You could read this online, right? So you could look at the documentation and see what are the different, just like your normal Word document. How do you save? How do you edit? How do you open a new tab? For Nano, for instance, you can have, if I have more than one tabs, if I open more than one Nano, I could go between those tabs. Okay. Let's go back to the lab. So that's about Nano. So we've learned how to log into our, what's it called? Our environment, our server workstation. We learned how to create a file using Scite. We learned how to edit using the same application. We also learned how to use Nano to open the particular file, and also how to edit the file. Okay, part 3. Working with configuration files. So as a SOC analyst or as an entry-level cybersecurity personnel, you might come into a situation whereby you need to edit some files, especially if they are configuration files. So in Linux, everything is treated as file. Yes, that's how the file system in Linux is. So whether you the memory, the disk space, the whatever you have in the Linux environment is treated as a file. Now, from the operating system standpoint, everything is a file. So it should be no surprise that the system itself is configured through files, known as configuration files. So depending on your permission level, that will determine what you'll be able to do and what you won't be able to do. In Linux, configuration files that are used to configure these applications are often placed in the user home directory, while configuration files that are used to control the system-wide service are placed in the etc directory, right? So what we want to do, we want to say ls command and see all of the files in our analyst home directory. So we go back, Control X, we exit, we clear screen, or we clear. Clear screen in CLS is for Windows, clear is for Linux. So I want to do ls. You see what I see? If I say ls-l, you see I'm going to see details with their permission levels, right? You see the difference between this guy, you just see the main files. Then ls-l, you see the items and their permission level. We'll come to that later on. So while a few files are displayed, none of them seems to be configuration files. This is because it's a convention to hide home directory hosted configuration files by preceding their names with a dot, right? Character. So that's normally hidden. So what can we do? We can say ls-le, right? Including that A option is going to give us everything included, including configuration files. Okay, you see the first time we just did ls, it gave us the file. -ls, it gave us all of the file details and told us their permission level. If we say ls-le, it's not going to give us everything, including hidden files, right? You see, hidden files that were ordinarily not showing. You see, they are not showing up. So we want to learn, how do we edit these configuration files? That's the purpose of this section of the lab. Now, use cat command to display the content of a bash RC file, right? So you could use cat to read files also. So I will run this command. So cat bash, where's the file? I'll not see the file on my end. Let me see. .bash rc. Let me just go ahead. Bash. Okay, so this is it. I don't know why it's not listed. Okay, look at it here. Okay, no, this is my command. I don't know why it's not showing up. Okay, this is it. Bash.bash rc. Right, so you could use cat to read it up. So this is the content of that particular file, right? The next thing is, do not worry too much about the syntax of a .bash rc file at this point. The important thing to notice is that it contains configuration for the terminal, right? It tells us how the terminal should look like. For example, the line PS, that is this first one, defines the prompt structure of the prompt displayed by the terminal. Username at host, blah, 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 shows by followed by a $, all in green. A few other configuration includes shortcut to commands such as ls and vi. In this case, every time the user type ls, the shell automatically converts that to ls-color to display a color-coded output for ls. Directories in blue, regular files in gray, executable files in green. So we're just trying to understand the configuration files within our Linux environment, and we're seeing what this bash file does, right? It has, for the command line interface, it shows the user at this. Then anytime you press an ls file, it shows, it runs a command adding color to whatever you have typed. For instance, if I say ls, you see it's now showing the regular file as white, the what was it called? The folders as green, and the rest. So that's a configuration file. Don't forget, we're learning how to view and how to edit configuration files. Okay, the next one is, while configuration related files to user applications are conveniently or conventionally placed under the user home directory, configuration files relating to system-wide services are placed in the etc folder. So how can we see such? You can just do ls/etc folder. We want to list all the items in etc folder. This is it, right? Very, very important files like, let me see if I can see a folder I will normally use every time. I'll normally use every now and then. See, for instance, your fonts, right? Your fonts, all of the fonts within this system. You have that configuration file there. You have your password, if you have to edit the password of this particular system. Some of your network configuration files, and your services, running services, your snot, that's the directory for that network monitoring tool. What else again makes sense here? So you see, but I could as well, let me CLS, or let me clear. I could as well do a directory or do ls-la. Am I seeing, what else? What am I seeing? Am I seeing the ETC folder? Okay, no. That's it. That's a folder within this, within the analyst core folder. Okay, so we've done this and listed all of these items for us. Okay, use the cat command to display the content of bash.bash hrc file, right? So we're trying to use this stuff also to view another file. This file is within this etc folder. So let's just try that. Let me clear my screen. Let me see. I can copy this. Hope it answers me. I paste. Same thing. There's a way to configure the. Let me see. Copy. I've forgotten how to make this guy work between our windows. Let me just type within the both environment. cat/etc/ bash dot bash rc. Okay, so this is a configuration file. You see it? Right? If not run interactively, don't do anything. So this is a configuration file. What are we supposed to know? What are we supposed to learn for this part of the lab? So this is the file. The syntax of bash.bash rc is out of scope of this course. The file defines the default behavior of the shell for all users. So most of the things for learning is just for you to understand the environment, right? You're not trying to learn a Linux configuration, a Linux setup, and the rest. You want to be conversant with your Linux environment, how to edit files, how to view files, how to open files, right? Whether they are normal files, text file, image file, configuration files, or the rest. So what you are seeing here is actually beyond the scope of this content. But what we want to understand that bash does, the bash.bash rc file does that it just tells us what the default configuration for users on the shell, what it is. If a user wants to customize his or own shell behavior, the default behavior can be overridden by editing this particular file located in the user home directory. Because this is a system-wide configuration, the configuration is placed under etc. So this is for every user that you create on this machine. Whereas if you want to edit the one for your own user, this one we are logged in, which is an analyst, you edit the first one we opened earlier on. That is ls ls-le. That is this one, right? You edit this particular one. .bash.rc. So this is for this particular user, right? But the one inside the etc folder of Linux is for every user on this virtual machine. Okay. So regular users do not have permission to write to etc because Linux is a multi-user operating system, just like Windows. So placing user application configuration files under etc would keep users from being able to customize them. So another thing we want to learn is saving files, right? So let's edit bash rc file and to change the color of the shell prompt from green to red for analyst user. So one thing we're going to do is that we're going to first open the application. So let me close this terminal. I'll just close it. I'll close all of them. I'll close this. I've opened quite a lot. I'll close this. So you see the tutorial or the guide on how to use the text editor. Okay, I'll close this also. That's my browser open. So I'm told to open up Scit. So I go to application, go to CyberOps, Scit. Once that is open, the next thing I want to do is launch it. Okay, select file, open to launch Scit's open file windows. So what I want to do is I want to open this particular file, right? And edit it, right? So this is it, file, open. Don't forget how we did it the last time for us to see hidden files. We'll select moment. Why is this not showing up? All files. If I indicate all files, I'm able to view the bash. I'm able to view the bash file. Let me see if I can see it. Okay, this is it. Bash.rc file. I open it up. Yes, this is it. So I've been able to open my editor, select it. Don't forget, it's hidden. It's a dot file. So you have to indicate all files like I did. Then I've opened it. Now we are told that locate 32 and replace it with 31. 32 is the color green, is the color code for green. 31 represents red. Of course, you could try several colors and see how they are, or look at the documentation for the bash rc file of Linux to see the different color codes. Then you could change and play around with it. So we want to change it to 31, which is red. 32, we want to change it to 31. We want to save it. I've saved. Click on the terminal application icon located on the dock at the bottom of this. The prompt should appear in red instead of green. So let's go back to our terminal now. Let's go back to our terminal. Yeah, so formerly it was green, now it is red. If I change this to, let me try 35, I save it. I close this. I open it up again. You see the color? So the different numbers, different colors. Okay, so you've just learned how to open both a normal text file like we did in the first part of the lab, and how to also open a, what's it called, a configuration file, and also edit that. Okay, so this is it. It has been changed to 31. It has been, so change 31 to 33. 33 is yellow. I changed to another color. So you could change the different colors and see what it looks like. So that's how to use these, how to edit configuration files. 3, editing configuration files for services. Now, system-wide configuration files are not very different from user application files. The Ninja-X is a lightweight web server that is installed on the CISCO CyberOps Workstation virtual machine. Now you have different types of servers. So you have the Windows servers, the Windows server, which is IIS. You have the Linux server, most of the times, which is Apache. Then you have Ninja server. You have different types of servers. Now, in this particular machine, they've configured this Ninja-X server, and we want to see how to do some labs with it. So first, open these configuration files in Nano. So this is the line of command. So I'm going to close all of these things I'm doing. I'm opening my terminal. Waiting for my terminal to open up good. So I want to type sudo. So while you type in sudo, you want to make sure that you have full permission to do all the things you are doing. So it doesn't tell you that, okay, you don't have permission to write that, you don't have permission to do that. nano-l/etc/ngix/custom_server.configuration file. So that's one of the ways you know a configuration file in Linux.conf. So our password is CyberOps. So we've opened it, so let's analyze it. Let me zoom this out. So don't forget, when you use Nano will typically, this is the file. Nano we open up everything still within your command line interface, right? So let's go back to the lab and see what we are told to do. So use the arrow key to navigate through the file. Down, 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 down to the end. Note, conventionally .conf extensions are used to identify configuration files. While the configuration files has many parameters, we will configure only two: the port ng x listings on for incoming connection, and the directory it will serve web pages, including the index HTML file. Notice that at the bottom of the window above the Nano command, the line is highlighted and listed in line 39. Change the port from 81 to 8080, line 39. So move down. Your mouse is not going to work, right? So you just use your what's it called? Your keyboard and move around line 39. It's listening at port 81. So we change that to 8080, right? Control S, I've saved. Next, move to line 47 and change the path from this to this, right? I bring this down so I can see clearly. All right, I'm told to move to line 47. So this is 47. Location, root. I've been told to change it from this to this. So user share ngx html slash. So you can move, you can't use your mouse, right? So use your keyboard, navigate to that particular place. You see, so I'm adding text underscore ed underscore lab, text underscore ed underscore lab, right? I've added that. Note, be careful not to remove the semicolon at the end of the line, right? Right? So that semicolon ends that particular statement. Of course, for most of all that program, that semicolon is very important. Press Ctrl X to save the file. So Ctrl X. Okay, I think I've made a mistake, right? I've made a mistake. Okay, let me go back and you can go back by using your what's it called? Your up arrow to see all of the commands that you've ever typed in this session. So I go to the last one I just typed now. I open it up. I go to where I made a mistake. I'm told to save it with another name. That's line 47. So I will go back. Okay, I will go back first to change the other stuff I did, because I think this should. Okay, this is the first line 39. This is the first. Just a moment. What's happening? Okay, so line 39. Is it line 39? Yes, this is it. So I go back because I think this file, the original file, it was 81 before. Yes, I'll save it. I go back to line 40. Let me go back to the instructions. Line 47. All right, 47. This is it. So I'm supposed to, this is how it is originally. So I will save this, right? So I've saved this. This is the original file, Control S, I've saved this. So let me go ahead now and rerun my instruction. My instruction is to first change this to 8080, 8080, then 49, or 47, to add that extra line, which is this. I'm told to change this from this to this, text underscore ed underscore lab, text underscore ed underscore lab, right? I'm told to be careful about this semicolon to make sure that it's not removed. So I'm now being told to press Ctrl X to save the file. Press Y and then enter to confirm the use, confirm and use this as the file name. So not Ctrl S, Ctrl X. So I did Ctrl S before, so I saved the original file. So I'm going to be doing Ctrl X. Are you there? So I'm being told to press yes. That is Y. And I'm being told to confirm to use custom underscore server underscore conf. This, right? So I think I'm fine now. So I'll just say, I'll hit enter, and that's fine. So I've followed the instruction. So the instruction is to open the file with nano, right? Sudo nano this, right? Once you do that, come down to this place and to line 81, change it to 8080. To line 47, change it to this. Then press Ctrl X, say yes, enter, and confirm it's saving as this, and you'll be fine. The next step is type the command below to execute the NIST using the modified configuration file. So what we're going to do is that we're going to see, let's confirm, sudo this -c, so sudo nginx.c custom underscore server .conf. Let me confirm that. Sudo as administrator nginx.c custom user, yeah, custom server. Enter. Password CyberOps. Okay. Click on the web browser icon on the dock to launch Firefox. Type this address. Okay, I will go to, sorry, I will go to applications. I will go to CyberOps. Sorry, I'll go to web browser or Firefox. And I type 127.0.0.1.80.80. So don't forget, we changed it from 81 to 8080. And this is our look back address, our local address. So I'm going to be searching for 127.0.0.1/8080, right? So to connect to a web browser hosted local machine on port 880, a page related to this lab should appear. Let's see, did we get the right stuff. Okay, the site could be temporary, unavailable to, or busy. Let me confirm. Okay, sorry. It should be colon 8080. Yes. So congratulations. As part of the working with text file lab, you have successfully configured NGI NX. So this is an ink server. So you've successfully configured this particular server. So the configuration is typically you may be changing the port number, editing configuration file, editing the path, and the rest. Okay, so it's a very straightforward lab. Yes, you could ask your question.
Sorry, sir. I just want to confirm. Prior to this congratulatory message, if perhaps we miss a step, is it that we'll have to restart your process again, or how do we go about it? Or we can just check from where we missed.
Come again with your question.
I said prior to this congratulatory message,
yes,
perhaps don't get this response.
okay.
How do we check the steps we can follow? Do we have to start from the beginning again, or how do we mitigate the likelihood of an error?
Don't forget, earlier on, the default port was what was it called? 81. So if I were you, before I even start, okay, if you even try 81, let's see what we get. Are you seeing? Because we've changed, we've reconfigured. So only what is going to work is 80, right? So we could go back, for instance, and we could go back and edit that particular file, right? Let me try something and go and edit the file to see this. That should be line 29 to see this. Is it 29? Just a moment. This is it. Listening out port 8080. If we change this to 1000, right? Let me save that. Come back here, refresh. I'm coming. Did I save that? What I just did now? Control X. So let me try this. And the thing about some of these labs is that they are in a controlled environment. So I didn't get that. Another thing you need to also be aware is that you see this congratulatory message, this user shared news file, HTML text file, edlab. It's a file that has been prepared for the purpose of this lab. This is the default HTML file. This is the file that has been adapted for this lab. Let me do one more thing. Let me go back to that file. Let me go back and change it back to the default 8080. But what I would do now is that from what we've learned so far, editing files, we could save, Control X. Let me try this 8080. Yes, still okay, working. So this is the file. We can see how to edit this file because that's what is showing this congratulatory message. So I could do, I could get to my CLI and a sudo nano, and I navigate to this. Very funny. Let me just reduce this. /user/share. slash nginx slash html slash text underscore ed underscore lab. Did you open? Did you recognize any file saved? It did not. Close Windows. Just a moment. Let me get something. Share this. Let me see if I can search it out from the file system. etc. Rather users. Share, then name server n. Okay, sorry, names, this is it. Then HTML, text edlab, this is the index. So I copy this directory. Then I say on my terminal, where's my terminal? I open up a terminal. Do I have any? Okay, let me open one. So I see, it seems I have some terminals open already even. Okay, so let me see, sudo nano. Yes, so CyberOps. Good. So are you seeing that file here? So this is the file that we could edit this file even. For those of us that do basic programming, HTML, you could add a break tag here. I cannot say you could add the header 1 tag, header 2 tag. I will employ most of us doing cybersecurity, learn how to do basic websites, learn how to do basic networking. It will help a whole deal in following up with most of this program. So I could say, sorry, H1, that's my header 1. So here I could say, welcome to the cyber breach training from ISO-sec Saltec, right? I could Control S. Yes, if I go back, because this is a file, we just learned how to open files, edit files, and the rest. So I've done the same thing here. And if I go back to this congratulatory message and edit, of course, I'm going to see the edit I just did here. So it's a header 1. If I change it to become a header 2, make this header, let's say header 4.
I think I get that now.
Yes. If I make it header 4, it should actually be small letters. Header 4 will typically reduce the size, right? So we've learned how to edit files, edit configuration files, make changes, and the rest. So let me see what's left in the lab. So let me see. Click on the web browser icon in the dock and launch Firefox. On the address bar, type this to connect the web server hosted on local machine on port 880. After successfully opening this homepage, look at the connection message at the terminal below. What's the error message referring to? Or which of the error message? I can't get that part. Error message. click on the browser on the dock to launch Firefox. We've done that. We open it up. It showed us after successfully running that. I can't get this. I pray this is not a mix-up in my lab files, but I fully know you understand what we just did now. We went further even to edit the particular file that is showing up here. Okay, and we had a success. What else again? Okay, I think maybe that has to do with the NIC server we had running earlier on. But we didn't have, did I close it? Let me see. Close this one. Close. Here, space 4. I didn't have error message. Okay, any other important thing here? Reflections. Okay, I think there's one here that have to do with can you edit the etc Nigex custom configuration file with Scit? Describe the process below. Remember, because the file is stored in under etc, we need to root permission to edit that. So you must add the sudo. You must add the sudo from the terminal below. Issue sudo this, right, to launch the site as root, as the root user. Reflections. Depending on the service, more options may be available for configuration. Configuration file location, syntax, and available parameters will vary from service to service. Always consult the documentation for information. Permissions vary, so the sudo gives you quite a lot of permission. So I will end this record now. I will, so that I can upload this for other students that are not able to watch this live. Then I'll check if I still have time. I'll take 1 or 2 more labs.